For a lot of teams, this is about rethinking delivery, frankly, and we can look at different places for inspiration now. Look at manufacturing. This isn't necessarily a place we think of when we go for wild innovations, but if you look at even the last 50 years of manufacturing, all of a sudden companies like Toyota and others have reinvented how they approach a number of different things. How they think about inventory, how they think about flow of units through their system, how they think about waste, how they think about keeping their people motivated and sustainable pace, right? How do they zoom out and view the entire flow of the system? Actually, we have a lot to learn from how manufacturing works and converting that to software. And not to say that software isn't a creative task. Sometimes it feels more art than science. But there's a number of things we can learn about the process of delivering that software that doesn't take away our creativity and instead simply just adds an improvement to the flow of work from team to team out to the customer and focus mostly on value. A huge part of successful modern manufacturing is about waste. And I think this is going to be an interesting conversation for us to have here because so much of this is something we don't think about, I don't think, in tech as much as we should. Look at knowledge waste. What's disrupting the flow of knowledge in an organization? And then even the absorption of knowledge. But if you look at the flow, hey, constant reorganizations, teams that don't talk to each other, software systems that don't talk to each other, right? That breaks up the flow of knowledge in an organization. You're wasting things that we should know. And there's things that disrupt the absorption of knowledge. Overstuffed PowerPoint presentations, constant review meetings, super complex reports that no one reads. All of this is wasting knowledge. Look at waiting waste, a terrible one. This causes some uneven processing. One team is going faster than another, and now we have unpredictable flow through the system. Sometimes you have specialized personnel. They can only do one thing. So they're sitting here waiting for something to happen so they have some work to do. We can see this all the time in tech. You're waiting for code to finish before you can test it. You're waiting for environments to be created before you can do anything. Waiting for approvals before you make changes. All of this waiting is one of the worst. Overprocessing waste, doing more work than is necessary. We do this because sometimes we don't know the requirements. How can I define gold plating a feature if I don't even know what the customer needs? Or we're writing long documents that nobody reads, giant specifications that don't matter. So overprocessing waste, again, gets in the way of us delivering value. Even motion waste. Another one talked about in manufacturing circles. It's toil on those who create the product. Sometimes you fix this by physically rearranging a workspace or changing your technologies or changing your process. Some examples of motion waste in tech could be long nights pushing software, repetitive manual testing, or even ergonomic things. There's a few more wastes that matter here. Transportation waste, moving products in ways that add no value, right? The moving cost, the lost time, the misdirection, damaging it in transit. Even in technology, we can see this if we're clumsily moving code between environments for no good reason. I'm wasting my time. I'm transporting things that I don't really have to. Correction waste. This is the idea of handling defects. So sometimes we rush to hit a deadline, even in manufacturing, so we can say we're done and we ship this batch. But too little emphasis is based on prevention. As we know, especially in manufacturing, defects after the fact are extremely expensive. So if I have to spend a ton of time after the fact correcting things, I'm dramatically increasing my cost and wasting time. Look at inventory waste. Those things that pile up and aren't producing income in manufacturing. Inventory is evil in a lean world. It leads to other waste. It means you don't have good flow. It's lumpy processing. If something goes wrong in item 5 of a batch of 100, I don't know until I'm done 100. So inventory in manufacturing is not something you're trying to have. Same with technology. And then finally, overproduction waste, making more than you need to, asking for more capacity than you need. Sometimes this is done to keep people busy, right? We produce more than we need just to keep going. But sometimes the setup, the work, that work can be completely unnecessary. And again, we're wasting time. We shouldn't build items when there's no orders or produce things in giant batches when somebody only wants one. So all of these different wastes, these 8 wastes I talk about, are pretty popular things discussed in the manufacturing space, and you can squint and imagine how many of these apply back to technology. So what's lean all about? I mentioned it in passing earlier, but this is really a way of thinking about customer value in manufacturing, thinking about ways to define the value stream, improving flow, and those sorts of things. So some of the essence of this is focusing on value. The goal of lean isn't to cut cost, but actually to free up resources so we can focus on adding more value. That first question you ask yourself in many cases is, what value are we adding from the customer's perspective? There's a lot of attention in lean on time. We just talked about waste. It's a huge part of lean. You're working systematically to eliminate all the non-value added processes in order to achieve your goal with the least possible effort and waste. Cycle time comes in big here. How do I reduce how much time it takes to accomplish something? This is why one-piece flow is the ultimate in lean production. It's eliminated most of Toyota's 8 kinds of waste that we talked about there. How do I almost send one piece of thing through the entire process so I'm not overproducing, I'm not wasting time, I'm able to have clean flow through the entire process? A lot of this too is about continuous incremental improvement. Lean's about not just having one process written into a book and everyone follows it. It's making sure we're always learning, using data, making sure that we are constantly improving the process, finding new ways to eliminate waste. And this isn't about burning out your people, frankly, the opposite. Eliminating waste is actually just 1/3 of that equation of making lean successful. Eliminating overburden of people and equipment, and then eliminating some of the unevenness in the production cycle is just as important. So how do we make sure our people aren't overburdened? And finally, some of this applies to the theory of constraints, which we're going to talk about in a moment, which is how do I think about the right places to spend my time trying to optimize? Let's talk about that. So with the theory of constraints, you might have a process here as I'm showing, where there's a couple of hotspots. These are bottlenecks. And in the theory of constraints, you look at this and say, look, the throughput is only as fast as the constraint, right? If I have a pipe and it shrinks to a tiny pinhole at one area, the flow of the entire pipe is the amount of that pinhole. You can imagine the same in technology, right? The constraint controls the whole flow. The whole throughput of the system is pinned by that. Now, what's fascinating here, though, and the theory of constraints looks at this and says, well, if I optimize before the bottleneck, before the constraint, then all of a sudden all I'm going to do is create excess inventory that's going to just sit and wait in front of that bottleneck. You can imagine if my bottleneck in IT is the QA team, but then I spend my budget this year on giving my developers better laptops, then what's the point? All I'm going to do is pile more code in front of a QA team. That's my constraint. That is my limiter of throughput. At the same time, same with goes after. So again, if my bottleneck, not to pick on QA, but if my bottleneck is QA, and I've invested all my money on this amazing continuous delivery software that runs after I've tested my code and packaged it, what's the point? That thing is just going to be starved for work while waiting for that QA team to process. So the idea here is that we want to elevate those constraints, spend our time fixing one of those. That could be a person, could be technology, could be a policy, could be a part of waste. How do we focus on those constraints, then move to the next one, and not accidentally spend our time on areas that don't actually improve throughput of the entire system? Now, you may not have thought you signed up for a Pluralsight course on manufacturing and lean, so how do we actually connect this back to software delivery? Can we do that? Of course we can. So some of this is reorienting towards bigger picture product thinking, right? Not just silo by silo, or team by team or component by component, but true value stream considerations. It's about removing wasteful processes. Find those rubber stamp processes. I bet you have one in your organization where it seems like 100% of the time the manager approves the thing. Why do you have that step? If 100% of the time it's approved, it can be automated or eliminated, frankly. Remove things that don't explicitly add value. Take a ruthless view of it and say, how can I eliminate waste to improve throughput and make my customer happier? This one can be tricky, but might be one of the most transformational things you do, which is delivering in small batches. Learn faster, experiment, introduce less risk and change into production at one time. This is frankly a security benefit. If I can ship quickly, that means I can patch quickly. So small batch delivery and development might be one of the most transformational things you can do in your team. Now, at the same time, continuous improvement is key here, of software, of process, of our skills. Right? This isn't about having fixed standard operating procedures that we just follow into perpetuity. Instead, it's about constantly figuring out how can we make the process better? How can we enjoy this more? How do we make our customers happier? That's a key part of how this can change what we think about software. And then automation is to remove some of the overburdening of staff. Get rid of toil, repetitive tasks, things that actually make our job not fun and probably introduce risk. We should all be spending time on the things that matter the most. And then attacking some of those bottlenecks. When I take a system-wide view, you start to see problems with flow that don't emerge when each team owns their little piece and optimizes locally. Instead, I'm looking at that bigger picture, and I'm not just saying my definition of done or my definition of good. We're able to look at the whole thing and deliver software that delivers value.